Exercise 1.3, question 3. Prove that the following are irrationals. Now here you have three parts. This is very similar to question number 2 that we did. Just watch that solution and you will be able to solve all of these on your own. Now in question number 2 we proved it, and here also we have to prove it, but we already saw these things in class 9. We saw that the sum or the difference of a rational and an irrational number is always irrational. So if you're adding one rational number and one irrational number or subtracting, the result has to be irrational. This actually will directly help you see that this third part here, 6 plus root 2, has to be irrational because 6 is rational and root 2 is irrational. This second point here says that the product and the quotient of a non-zero rational and irrational number is irrational. Yet again, product and quotient means if you multiply or divide one rational number with one irrational number, even then the result will be irrational. And that is what you see here in parts 1 and 2. Part 1 has a quotient, it's division, and part 2 has multiplication. Now these things, although when you see them you will be able to tell them because of these two results, the goal here in this exercise in question 2 and 3 is to prove these cases. Now as I said, the proof is exactly how it was for question number 2. Let's just get started. Okay, let's read this together now. Prove that 1 over root 2 is irrational. Now you know how the proof is going to work. You again suppose to the contrary on the reverse side. You suppose that it is rational. Then what that means is that this can be written in the form a by b for integers a and b, where b is not 0 and a and b are co-prime. That is, they have no common factor at all. Now from this what you can do is you can find out square root of 2. So really if this is 1 over square root of 2, then you're just taking the reciprocal. So square root of 2 will be equal to b by a. Now you know what, whenever you write this, the rule is that the denominator should not be 0. Now right now from here I can't explicitly see it mentioned that a is not 0. But a definitely is not 0. Think why. If a was 0, then no matter what b was, 0 over b would have the value 0. It would never be equal to 1 over root 2, right? So because of this, you can be sure that a is also not 0. Now when you see this is also in the form integer divided by integer, where the denominator is not 0. So from this, it appears that this thing here is rational. That is what the very definition is, right? But if b by a is rational, then square root of 2, which is equal to b by a, is also rational. But that cannot be true. You know that square root of 2 is irrational. So you have reached a contradiction. Now, why did you reach this contradiction? Because of your incorrect assumption that 1 over root 2 is rational. And so, if that was incorrect, then what is correct? The correct version is that 1 by root 2 is irrational. Let's go to part B now. Okay, here we go. We have to prove that 7 times root 5 is irrational. Same thing again, suppose to the contrary that this is rational. Then it can be written in the form a by b, integers a and b is not 0, and a and b are co-prime. From this again, I will find the value of square root of 5, which will be equal to a over 7b. Now if b is not 0, then 7b is also not 0, and a and b are integers. So this again is written in the form of a rational number. So that means a over 7b is a rational number, which then will mean that square root of 5 is also rational because they're equal. But this is a contradiction. Since we know that square root of 5 is irrational, contradiction has arisen because of our incorrect assumption that 7 root 5 is rational. That means if this assumption is wrong, then your conclusion is that 7 root 5 is irrational. Let's look at the last part also. It's identical. Pause the video and try it first before you see my solution. Here's the last part. You have to prove that 6 plus root 2 is irrational. Again, supposing to the contrary that this is rational, we will get that it can be written in the form a by b, where a, b are co-prime and b is non-zero. From this again, you know the drill, you will find out the value of the square root alone. So that will be a over b minus 6. Then if you simplify this, you can take the LCM b, this will be a minus 6b. Now again, the denominator is still b, so it is still non-zero, and if a and b are both integers, then a minus 6b is also an integer. So this is in the form integer divided by integer, where denominator is non-zero, which means this here is a rational number. And if this is a rational number, then square root of 2 is also a rational number, because square root of 2 is equal to this, as we see. But this is a contradiction, since we know that square root of 2 is irrational. Now this contradiction came up because our assumption was wrong that 6 plus root 2 is rational. So if 6 plus root 2 is rational is incorrect, then actually 6 plus root 2 is irrational. And that's it.